So hi everyone, my name is Ali, and in this project I work on NLP analysis of Yahoo questions for tagging application. So the goal of this project is to tag and classify a text based on the content. And this has the daily application in our lives when we are searching through the e-commerce websites, using the search engines, and also when you're using social media. So the tagging and classification improves the browsing and customer experience. So it's going to make it easier for the customers to find the items they need. And also it helps them to identify related contents on the website. So that's why I decided to use the data sets from the Yahoo answers, which include the questions and answers by the user, and then classify each question into one of the 10 categories defined by Yahoo using NLP analysis. And on the right-hand side, you can see those 10 categories. I selected 140,000 data points for each category, so that the total of 1.4 million questions and answers. And one point to mention that figured out in our study is some of these categories are relatively similar to each other. Family with society, entertainment with the sports, and education with science. And I'm going to talk about it in more details in the next slides. So in terms of the workflow, I started with EDA. I used a balanced document dataset. Then I performed text featureization. I used Unigram, TF-IDF, and Bigram TF-IDF vectorization to get my features. Since I got too many features at this point, I decided to use feature reduction. I used the chi-squared method and minimum and maximum document frequency to minimize the number of features that I'm using. After splitting my data into training and test, I used 4 different classification models to fit to my training data points. And also I perform model optimization and hyperparameter tuning to find the best model and the best hyperparameters. And after having those models, I use those models to predict on my test data set. In this slide, you can see the results of those 4 classification models. As you can see, logistic classification has the highest score of 0.72. And I have to mention that there is a publication by Yahoo and they got the accuracy of 0.68. So we got relatively good results with logistic classification in this case. If we look at the bottom left-hand side, and if we look at the rock curve, we can see that for most categories, we are seeing a pretty good prediction, except for a few, like for business and finance and for education. If we look at the confusion matrix for those 2 categories, we can see that the numbers, the true positives for those categories are relatively lower compared to the other categories. And I'm going to talk about that in the next slide, why this misclassification happens. And one last interesting point is we can also take a look and see what are the most important keywords per each category. So here I'm showing you 2 categories, sports and business and finance, and the most keywords within them. So for sports, we are having the NFL, football, cup, cricket, and for business and finance, we are having the stock, investing, mortgage. So this is something interesting that came out of our model. Then I took a look at our model to see why misclassification happens. And I found 2 main reasons. First, incorrect tagging by Yahoo. So Yahoo itself mislabeled some of the questions. Giving you an example, the question by the user was, for 6 months, I have received this message. Can you help me, please? And the solution and answer was to delete the Yahoo Messenger application. This is not apparently related to business and finance. And if we look at our model, it's picking up on words such as the DLL, file, Yahoo, Messenger, and predicts with 93% chance that it relates to computer and internet. So our model is outperforming in this case. And the second reason for misclassification is related to complicated sentences and structures. So giving you an example again, the question was about how could you distinguish a plant cell from an animal cell when looking in a microscope? So far the question is related to the science. But then in the next sentence, they are asking about for my bio lab final. And this sentence alone, but with these 3 keywords and the weird structure of 4, has changed the class from science to education. And that confuses the model. And maybe the sequential model helps in the future. Here are some of the stacks that are used in this work. And in terms of the future work, I'm planning to build a LSTM deep learning model and try feature engineering by transforming the corpus into a list of sequences using word-to-vec model, and also apply transfer learning model to the corpus using Google's BERT module. So thank you for your attention. These are my contact information. Please let me know if you have any questions.